There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and the same time and go in the same direction. After how many minutes will they meet again at the starting point? Given the time taken by Sonia to drive one round of the field is 18 minutes, and the time taken by Ravi to drive one round is 12 minutes. Now, the time taken by both of them to meet again is simply the LCM of 18, 12. That is, we know the factorization of 18 as 2 into 3 square and 12 can be expressed as 2 square into 3. Thus, the LCM of 18, 12 is given by 2 square into 3 square. That is 4 into 9, which is equivalent to 36. Thus, Sonia and Ravi meet again after 36 minutes from the starting point. Find the LCM and HCF of A equal to x square y z cube and B equal to x y square z. So given A equal to x square y z cube, which can be written as x square into y into z cube, and B x y square z, that can be expressed as x into y square into z. Now the LCM of numbers is x square into y square into z cube. That is x square y square z cube. And the HCF of the numbers is simply the common terms, that is x into y into z, that is given by xy z. Here we have a note that let P be a prime number, and if P divides A square, then P also divides A. Let us prove root 2 is irrational. Now let us assume that the root 2 is rational. That implies we can express root 2 as P by Q. P and Q have a common factor, then we must divide both the numerator and the denominator by the common factor. That is root 2 equal to A by B, where A and B are cofactors. Now rearranging the terms as root 2 into B that equal to A. Applying squaring on both sides, we get root 2B whole square, which is equal to A square. That is 2B square equal to A square. Here you can see if you multiply a B square by number 2, you're getting it as A square. That implies you can conclude 2 divides A square. That implies 2 divides A. It will be statement number 1. Thus, we can express A as 2 into some constant number C, where C belongs to a set of integers. Now substitute A in equation number 1. That implies 2B square equal to 2C whole square, which is given by 2B square equal to 4C square. So we have 2 ones are 2 2s are, that is B square equal to 2C square. You can rearrange the terms as 2C square equal to B square. Thus, we can conclude 2 divides B square, and hence 2 also divides B. It will be statement number 2. From the statements 1 and 2, we can say that 2 is a common factor of both A and B. It contradicts the fact that A and B are coprime. This contradiction has arisen due to the assumption that root 2 is rational. Thus, we can conclude that root 2 is an irrational. Show that 5 minus root 3 is irrational. Let us assume that 5 minus root 3 is rational. That implies we can express 5 minus root 3 in the form of P by Q, where P and Q are integers. If P and Q have a common factor other than 1, then we must divide both the numerator and the denominator by the common factor. That implies we can express 5 minus root 3 in the form of a by b, where a and b are coprimes. Now transpose this 5 to RHS, that is minus root 3 equal to a by b minus 5. Next, if you multiply both LHS and RHS by minus 1, that is root 3 equal to 5 minus a by b. And next, if you take the LCM, that is root 3 equal to 5 into b, that is 5b minus a whole divided by b. Since a and b are integers, then 5b minus a by b is going to be rational, which leads to root 3 is rational. It contradicts the fact that root 3 is irrational. This contradiction has arisen due to the assumption that 5 minus root 3 is rational. Therefore, we can conclude that 5 minus root 3 is an irrational. Show that 3 root 2 is irrational. Let us assume that 3 root 2 is rational. That implies we can express 3 root 2 in the form of p by q, where p and q integers. If p and q have a common factor other than 1, then we must divide both the numerator and the denominator by the common factor. That implies 3 root 2 can be expressed as a by b, where a comma b are coprimes. So we can thought 3 root 2 as 3 into root 2, which is equivalent to a by b. Now transpose the 3 to RHS, that is root equal to a by 3b. Since a and b are integers, then a by 3b is going to be rational, which leads to root 2 is rational. It contradicts the fact that root 2 is rational. This contradiction has arisen due to the assumption that 3 root 2 is rational. Thus, we can conclude that 3 root 2 is an irrational. Next, choose the correct option from the following. Statement number 1, pi is rational. Statement number 2, 22 by 7 is rational. We know that pi is a non-terminating or non-repeating decimal. That's why it is irrational. Thus, first statement is clearly false. And here you can see 22 by 7 is in the form of p by q. That's why it is rational. Thus, the correct option is B. Like this content, please like, share, and subscribe to our channel.